Hello, and this is Sunny. Welcome back. Last time I talked about three basic operations of STP to create a loop-free network: selecting a root bridge, calculating the best path to the root bridge, and blocking unwanted links. But I skipped the details of a root bridge election, which is my today's topic. Root bridge election is based on a switch bridge ID or BID. BID is combinations of two parts, a 2-byte priority field and a 6-byte switch MAC address. So a bridge ID is 8-byte value. Root bridge election process is simple. All interconnected switches exchange their BIDs, and whoever has the lowest priority field value would become the root bridge. If there's a tie, whoever has the lowest MAC address would become the winner. Here we have three switches, and they have the same default priority value, 32768. Then the MAC address of a switch would become a tiebreaker. Switch A would be elected as the root bridge since it has the lowest MAC address. But how does it work? Here is how the election starts. Every switch multicasts its message, Hello BPDU, in which each switch declares itself the root bridge. BPDU stands for Bridge Protocol Data Unit. BPDU is a frame containing information about spanning tree protocol, and Hello BPDU is used by switches or bridges to share information about themselves. It is used for electing a root bridge, determining port rows and states, and blocking unwanted links. To put it simply, Hello BPDU is used to configure a loop frame network. In Hello BPDU frame, there are many fields, but today we only focus on three fields: root ID, root path cost, and bridge ID. Root ID is root bridge BID. Bridge ID is BPDU sender's BID or the source bridge ID. Root path cost is the best path cost to the root bridge. A switch multicast Hello BPDU using a unique MAC address from origin port and a multicast destination MAC address. On layer 2 switch running STP, each port has unique MAC address. We don't want to go to much details here, but just remember, each port of a switch is uniquely identified. Back to this example, these three switches send out their Hello BPDUs. Basically, each switch declares itself the root bridge. Let's check with switch A first. Switch A sends out its Hello BPDU to both B and C. Let's just simplify the frame and we focus only on the middle three fields. From its Hello frame, switch A sets root ID to its own BID. It simply tells the other switches, "Hello everyone, I am the root bridge." And the path cost value is set to 0 because the path cost to itself is, of course, nothing. Switch B does the same thing in its Hello message and sets its own bridge ID in the root ID field. The path cost is also set to 0. Switch C does the same thing. Basically, they all claim they are the boss in their Hello BPDUs. The problem is only one can be the root bridge. What they do next is compare their Hello BPDUs and to elect a real boss. Here is what they do. When switch A receives Hello BPDUs from both B and C, it checks and discards their BPDUs because its bridge ID is lower than both B's and C's. Switch A keeps its original Hello BPDU and still believes it is the root bridge. When switch B receives the Hello BPDU from switch C, it compares and finds its BPDU is superior and thus discards switch C's Hello BPDU. However, when switch B receives switch A's Hello BPDU, it finds switch A's bridge ID is lower, and it would say, well, switch A is the winner. Therefore, it modifies its root ID value by replacing its own bridge ID with switch A's bridge ID. It also calculates the path cost to switch A like 4, and then sends the modified Hello BPDU to others. When switch C receives a Hello BPDU frame from switch A and B, switch C finds switch A's is superior BPDU. Switch C changes its own Hello BPDU value too, like setting the value of the root ID to switch A's bridge ID and calculating the path cost to switch A like 1. Then it sends its modified Hello BPDU to others. This way, switch A, B, and C exchange their BPDUs again and agree that root bridge should be switch A. Once the root bridge is decided, path cost to the root bridge is calculated. Root ports, designated ports, and blocked ports are determined. STP has created a loop-free network. Once the network is stable, only root bridge switch A multicast Hello BPDU to other switches every 2 seconds. Sometimes we want a switch to become the root bridge for some good reasons, like the switch is the most centralized switch, or the switch is least disturbed. In this situation, we need to configure the root bridge to ensure that no matter how the network changes, our initial root bridge will remain. To achieve this, we simply configure the bridge priority value so that it is always the lowest. In summary, switches use Hello BPDU frames to exchange information to select their root bridge and configure a loop-free network. But what happens if there's some network change, such as an active link breaks or a new switch is added to the network? How does STP react? Please stay tuned. I hope this video is helpful. If you want to learn network systematically, please check out my playlists. They are organized by topics. Thank you very much and see you next time.